All right, if you guys have not submitted your attendance in Canvas, make sure you do so. And then also we are in lesson 3.4 in Amplify. All right, so last lesson before we take our unit test next week. So we are going to review tomorrow, and we're going to review a little bit more next week when we have time. All right, so unit test will be next week. That will be our end of unit assessment, and will also be the final. All right, so lesson 3.4 is reasoning about the pod's motion. So we're putting everything together, and we're only talking about what happened to the pod and the docking station. So by the end of class, you're going to be able to use some evidence to support a claim on the motion of the pod and the space station. All right, so activity 1 is going to be our warm-up. We're going to review some new data about the pod and the space station and then answer the question below it. All right, so this is the new data we're given in Amplify. Dr. Gonzalez has written us a letter. So go ahead and look at this warm-up. I'm going to read it real quick. It says, you've done excellent work in investigating how collisions affect different objects, and we're looking forward to your final report. In case you might find the following helpful for comparing the speed of the pod and the space station, after the collision, here are their masses. It says the pod's mass is 1,100 kilograms, and the space station is 415,400 kilograms. All right, so you have got a question down below here. If you haven't started to answer that, make sure that you do. It asks, how can you use this information about mass to help you to compare the speed of the pod after the collision to the speed of the space station after the collision? All right, go ahead and answer that question. Just take a few minutes. When you get done, make sure you hand it in, and you will move on to that second tab. All right, take a couple seconds to get that finished up and hand it in. All right, so on Tuesday, you were given some homework to do. You had this little comic strip, and then you had a reading. And so we're going to look at this comic strip one more time, and I want to see how you guys finish this explanation to Sherman. All right, so it starts with, did you see that? When the ball crashed into the pins, those lightweight pins went flying, but the heavy ball barely changed its speed. Said, yeah, the ball must have exerted a really strong force on the pins, but the pins didn't exert much force on the ball. Says, sorry, Sherman, but a pin exerts the same force on the ball that the ball exerts on a pin. It's a collision. He said, huh? Don't the forces have to be different to cause such different effects? And then it says, actually, Sherman, the forces in a collision are equal. The effects are different because. All right, I want you guys to finish that sentence. Let me know what you guys put in the chat. So how did you finish that sentence? Y'all can either unmute yourself or put it in the chat, whichever one. All right, so one ball can have less mass and one can have more because the bowling ball and the pins are the same mass every time, and when the ball hits the pins, it has the same force of knocking them down every time. All right, the bowling ball has the same mass every time, and then the pins have the same mass, but those masses are different. So the bowling ball is more massive than those pins. Alexis, we're not doing a pair deck. We're just going through the slides. All right, so we know that this had something to do with the mass of the bowling ball and the mass of the pins, right? The force between them is always the same, but the effects are different because of the mass. Now, for activity 2, what I'm going to tell you guys right now is that we are staying in Amplify for this whole lesson. So if I'm going too slow for you, then don't be afraid to kind of just work ahead. If you understand what's going on, that's totally fine if you want to work ahead. But make sure that you're listening because you might get something wrong or you might mess something up and you might need to go back and fix what you're doing. But if you are reading the directions and I'm going too slow for you, then that is totally fine for you to work ahead on your own and Amplify. All right, but make sure you're listening. All right, so for activity 2, it wants us to review the report to Dr. Gonzalez's directions and model how to use the reasoning tool. Okay, so we're going to be using this reasoning tool. And then remember, at the beginning of this chapter, I told you guys we were going to write a final report to the space agency. And so the report will provide a complete explanation of what happened to the pod during the seconds that communication was lost and after the collision. So let's review some of the parts to our report. So we've got 2 parts to this report. Part 1 is going to explain those missing seconds. And the question was what happened that caused the pod to collide with the space station. So this is what we looked at in chapter 2. We tried to figure out what happened to the pod during those missing seconds. And we had said something about, I think there were two claims that we had to pick from. And we eventually picked claim 2 that talked about it hit the space station, bounced off. And then the claim 1 that we had disagreed with said that the thrusters caused the pod to move in the opposite direction. Okay, so that's what that part 1 is. Part 2, we are going to use evidence to argue for the claim that best describes how the pod and space station are moving after the crash. Okay, after the collision, we're talking about their movement. So for claim 1, it says the pod is moving faster than the space station. Claim 2 says the pod and the space station are moving at the same speed, and claim 3 says the pod is moving more slowly than the space station. So you guys are going to be able to pick a claim here in a second for that part 2. All right, you guys remember the scientific argumentation little chart starts with a question, then a claim is next, and then you have your evidence and reasoning. So we're going to be given some evidence today, and what we need to do is the reasoning part of it. So we're going to explain how our evidence supports or refutes a certain claim. Right? This is our reasoning tool. I hope this looks a little familiar. This is what we're going to be working with today. All right, for now, we're going to focus on this first part of the argument. And this is what tab 2 is going to be on. This is what it's going to look like. So what happened to the pod when communication was lost? All right, so the middle column is what you guys are going to be filling out. You're given the evidence. You're given the therefore column. Right, that therefore column, that last column is for that claim 2. Okay, so remember, we already determined that claim 2 was best supported by the evidence that we had. So the thrusters only slowed the pod, it didn't stop, and it hit the space station and bounced off in the opposite direction. All right, so let's discuss these two pieces of evidence real quick, and you guys can fill this reasoning tool out. All right, evidence A. So evidence A says the thruster force was the same strength as other missions, and it was exerted in the opposite direction. All right, so evidence A was helpful because it revealed that there must have been something different about the pod that caused it to move in the opposite direction. All right, so in that middle column, you're going to explain why that evidence A matters and how that supports the claim 2. All right, so evidence card B says the pod's mass was 1,100 kilograms and it was 130 kilograms more than usual. Right, so we learned that this mass affects how objects change velocity when a force is exerted. And so evidence B tells us that the mass of the pod was more than normal. All right, so evidence A and B work together to support this claim, and so we know that the force exerted on the pod was the same, but the mass of the pod was different. All right, take some time if you have not already. Make sure you fill in that middle part of this chart. Then when you get done, click hand in, and it will move on to the next activity, which is tab 3. Once you guys get done, make sure you hand that in. All right, so that next activity is going to be that third tab. So now we're going to focus on the second part of our report. All right, make sure you get that finished up. Each of these activities shouldn't take us too long because they are smaller parts that will eventually lead to a whole in a writing. All right, so this activity 3, we're going to use the evidence given in the reasoning tool, so the mass of the pod and the mass of the space station, provide reasoning and state what claim the evidence supports. So right now, we're going to pick one of those 3 claims that we think we can best support. All right, so we're going to use the reasoning tool to help us reason about the new evidence about the pod and the space station and how it can support one of the claims. So let's take a look back at the 3 claims. All right, so it says after the collision, how does the pod's motion compare to the motion of the space station? All right, so claim 1, 2, and 3 are listed right there. And it wants you to read the evidence in the first column and use this reasoning tool to reason about the evidence and evaluate the claims. All right, so I would suggest right now, make sure you're in Amplify. You're in tab 3, and I would suggest looking at this evidence. So you're given the mass of the pod, you're given the mass of the space station. I want you to pick the claim that you think you can best support and put that claim in this therefore column. All right, so if I'm in tab 3, you will put claims 1, 2, or 3 right here, and then you'll type out that claim. So if you picked claim 2, you say the pod and the space station are moving at the same speed, and then you explain how this evidence, so how the mass of the pod and the mass of the space station support that claim. And that is the only chart that you have to fill out for this activity. All right, so take a few minutes and then click hand in. So once you get done with that, make sure you click hand in. All right, guys, so I want to know what claims that you guys picked. All right, so in the chat, or you can unmute yourself, just let me know what claim that you picked from that last activity. All right, I got a few people sending me messages, and all three of you picked different ones. All right, I need some more people. Let me know what you picked. All right, got two more. This is interesting. Okay, good, Kendall. All right. So I've got people all over the board. So I've got people saying claim 1, I've got some people saying claim 2, and I've got some saying claim 3. All right, so remember, the mass of the pod is 1,100 kilograms, so 1,100 kilograms. The mass of the space station is 415,400. All right, so we know that the space station is way more massive than the pod, right? So if something is more massive, if there is a collision, which one of those is going to experience the greater change in velocity? The less massive or the more massive thing? All right, Natalie said the less massive thing. So which one is going to experience the greater change in velocity? Which one's gonna bounce off faster? Is how we could probably say it. All right, right. So the pod. Okay, that's what some people are saying to me. They're saying the less massive object. So if you're telling me that claim 3 is correct, the pod is moving more slowly than the space station, you're contradicting yourself there, right? The pod is less massive, so it's got to be moving faster than the space station. Now, claim 2 is not correct because the pod and the space station are not the same size. They're not the same mass, right? So the only one that could be true is the pod is moving faster than the space station because of the mass. And we know that the less massive something is, the greater change in velocity it could have. All right. So after that, we're going to move on to a model. So you guys have seen the modeling tool multiple times. But what we're going to do now is we are going to model what happened before, during, and after the collision of the pod and the space station. All right, so you guys are going to create some diagrams that help explain what happened to the pod after the collision. And so the modeling tool is going to look something like this picture here on the left. All right, so you can go ahead, make sure you're in activity 4 or tab 4 of Amplify, and you'll see something like this. All right, it's got your instructions there. It wants you to open up the modeling tool, and when you're done, press hand in. Your goal is to model the forces exerted when the pod and the space station collided. So the things that you have to do. So when you're in the modeling tool, the things that you need to do are show the locations of the pod and space station during and after the collisions. So it wants you to drag those two objects up here to the top. So I've kind of already dragged those objects, but you guys need to drag the force into the during force and the velocity into the after force, showing what happened to both of these pods or the pod and the docking station after that collision. All right, I want you to show the strength of the forces exerted on the object during the collision, and that's when I just talked about dragging those arrows, those pink arrows, to that middle part, to the during force. And then it wants you to show the final velocities of the pod and the space station. So that's where you will drag these velocities here in the middle to this after force. And then it gives you some clues that the medium mass object represents the pod and the large mass object represents the space station. Okay, so the darker one represents the space station, lighter one represents the pod. Okay, take a few minutes to get this model filled out. If you want to look at mine right here and drag the objects to where they need to be, you can do that and just look at my page, but you need to drag the velocity and the force to where they need to be. And when you get done, click this blue hand in button up here at the top left. All right, the next thing that you're going to do after we do this model is we're going to write a convincing argument to Dr. Gonzalez. And so what she is interested in is understanding this cause and effect relationship between the thrusters in the pod, and then also between the colliding objects, so that pod and the space station, and their change in velocities. All right, so we're going to review these writing prompts real quick. And then you guys can refer to the completed reasoning tools and models for help with your explanations. Okay, there are some suggested words and phrases that are in Amplify when you get to that page just to help you out. These are most of our vocab words. All right, so go ahead. This is technically the homework for this lesson. And so you guys are going to be left with the self-assessment and the weekly check-in to do for out of class. All right, so you got part 1 and part 2. So what we did in the second tab here, we talked about this part 1. So we talked about what happened to the pod during those seconds when communication was lost. All right, you can go back to the second tab. You can put what you have in your reasoning tool into your writing for that part 1. All right, for this part 2, the question was, after the collision, how does the pod's motion compare to the motion of the space station? You can go back to tab 3 and take some of this stuff and put it in your writing here. Okay, so you are answering these 2 questions. These are the 2 parts of our report. All right, this is what we're going to be doing with the rest of the class. I know we've got quite a bit of time left. So after you get done with this homework, you can move on to the self-assessment. So while you're working on this, I'm going to talk about the last two things that you're going to do. So keep working if you are working. If you've fallen behind just a little bit, that's totally fine. Just make sure you get to that homework part. All right, so for activity 6, you're going to do the self-assessment. You are only doing the 4 questions that say yes or not yet. You're only doing those 4 questions where you do the drop-down menu and put yes or not yet. You do not have to do any of the explanations. The last thing that you need to do once you get done with your homework and once you get done with the self-assessment, you're going to do that weekly check-in on Canvas. So for lessons 3.3 and 3.4, there should only be 4 questions in that weekly check-in, and it's worth 10 points. All right, so make sure you're focusing when you do that. If you need to use anything from this week, you can use anything that you have to answer those questions in the weekly check-in. All right, and my last little announcement, our unit test, our final is next week. All right, I think ours is on Thursday, I think. I'll have to get back to you guys tomorrow. We'll look at the final schedule and we'll start reviewing. All right, so get done with this homework part in Amplify, and when you are done with the homework, you may leave. All right, I'm going to stop sharing my screen and go and check who has finished everything, and you may leave once you have.